0. So this is just going down the texture. Alright, so that returned. Now it's going to the bottom left. Distance R. I would expect it to, the red to go so that's the goddamn height map for this thing. And this is the distance, so well, let's see how it works. I guess what we should do here is if current distance dot r equals 0, then we just return, because we want to stop propagation on this node. We don't want to keep going. Because we've already hit something that's smaller than us. Yeah, we ran into a pixel that is already been opened, already finished, done. So we don't have to worry about it. And we could probably optimize this so it only goes in certain cardinal directions, like you can only go positive Y, you can only go negative. And we can like add X, add Y, X step, Y step, sort of stuff. But it should immediately cancel out, so it shouldn't be too wasteful. So this thing got set to just completely black. So completely black is that the distance is always 0? Why would the distance always be 0? Well, let's just log it out and see what it's doing. And we'll just slowly fix all of our algorithms. Blah. Yeah, right now I'm just going through and I'm calculating the distance to shore. I've already calculated where the shore is. I'm just propagating the distance across a texture and trying to do it just pretty simply. It should be once we're done, just a very small amount of code. And trying to do it with a few optimizations so it's not some ridiculous n squared test everything against everything sort of crazy crap. Let's go to our output log and see what this did. Okay, so we set a whole bunch of stuff to like 51. Let's see. 1616 to 95? This is a 32 by 32 texture. How in the hell have we counted up to 95? Alright, so 1616 got set to 11 at the final value, so So it appears to be a black texture, but it's actually not completely black. It's... Let's go to our material for this thing. Multiply this by, you know, like 10. Yeah, we can see we actually do have some distances here that are working properly. Alright, well let's do a 256 by 256 texture then, and see what it looks like. Okay, this thing's gonna explode because of the logs are gonna go absolutely insane. Alright, let's see. We should also be able to have like a propagation direction, which is like if it can go left, right, up, down. Because let's see, as we open these pixels, we can go like up, and that pixel should be able to go up. And a pixel that goes to the up and out should be able to go up, and it should be able to go to right. It should be able to go up. It should be able to go right. It should be able to go up and right. So we need like the cardinal direction that this pixel is traveling. So we want like int 32 direction. So what we want are our directions on this thing. So we should have direction of 0, which means go in all directions, and 32 direction. So if the Alright, so let's see. The directions will be going clockwise will be so 0, 1, 2, 3, 4, 5, 6, 7, 8. Alright, so if the direction is 0, One, 2, 3, 4, 5, 6, 7, 8. Alright. So if the direction is 0, alright. So let's see. We should be able to go up. Let's start with this direction. So we should be able to go up if direction equals 0 or direction equals 1, or direction equals 2 or direction equals 8. We should be able to go up. Okay. So we should be able to go up and left. Only if direction equals 0 or direction equals 8. We should be able to go up and right. Only if direction equals 0 or direction equals 2. And this direction here is, this is straight up, so that's direction 1. This direction is direction 8. This direction is direction 2. Okay, so this is to the left. We should be able to go left if direction equals 0, or direction equals 8, or direction equals 7, or direction equals 6. And this direction is direction 6. Okay, so if direction, this is direction, right, so this is direction 3. Right, so if direction equals 0, or direction equals 2, or direction equals 3, or direction equals 4. We can go in 3. This direction is down and down, which is direction 6. We should only be able to go in direction 6 if direction equals 0 or direction equals 6. Alright, this direction is down, which is direction 5, so we should be able to go in direction 5 if direction equals 0, or direction equals 6, or direction equals 5, or direction equals 4. And let's see. Alright, we'll finish this off. This direction is to the right and down, so this is direction 4. So we can go in direction 4 if direction equals 0, or direction equals 4. So let's think about this real quick. If we are moving diagonally, we move diagonally, so we were direction 4. Let's just make a better grid here. Alright, so we were moving in direction, we are this block. Direction 1 is just going to go up here, so direction 1 will cover this, and then this, and then this. Direction 2 is going to cover this, and then it's going to be still direction 2, so it's going to cover this, and it's going to cover this, and this. And this guy is now direction 1, so he's only going to go up this way. But this guy is still direction 2, so he's going to cover everything else. And this will be 2 again here, and this will be 1, so we should theoretically have everything covered. I don't think we're going to have any gaps. So let's see how that goes. And there is no direction 0 except the first one. And this should prevent those big numbers from going on there. It should actually save a lot of time because it's only going to go in one direction and not double back on itself. As it's propagating, it was like propagating back on itself and all around and everything. And that was causing a lot of log spam, crazy town. So let's take a look. Let's see what we actually got going on here. I love just having magic numbers and everything in here with direction zeros and ones. I've got my nice little picture that I drew right there with all the brilliant directions. Alright, so it's 32. We'll construct it. And let's see what our material looks like. Yeah, we didn't save our multiply in our material. So let's try our 256 height map. Well, it doesn't look right, does it? Looks like it's going in some directions properly, but it's not going in all of them. Like, it's not actually opening things properly. So why would that be? Well, we know we're going to visit every pixel, so if we visit something and the current height is 0, then we can just return. Like, we can just say, like, the current thing equals 0. And return. Well, no. What we want to do is we want to say propagation equals 0. Alright, so it's going to be if direction equals does not equal 0, then return. Otherwise, propagation is going to be 0, current distance is 0, and we're good to go. Yeah, we can just get rid of this. Okay, so this might actually work better. Alright, so if you run into something that is, you know, a thing, we're gonna stop propagating and all that. So like we ran into a pixel and this higher level loop is actually going to stop, open that pixel and then start doing the propagation all over again. And the reason we were having all these problems was because it was already getting written in there. For the zeros, like it would travel over and run into something and stop, as opposed to what it should have been doing. Alright, that's looking pretty cool. That's looking like we're actually getting some distances properly to our shoreline. And it's all square and everything like that, so it's not like we're not doing the distance formula properly, right? Like we should be using a float for the distance and setting it in there. So why don't we just go ahead and do that? And I think fmath has a ceil function. I mean, we want to floor this value. It should be lower. They don't have a fucking floor function? Are you kidding me? Okay, they do have a floor function, but they don't have it in their fmath documentation online. It's lame. Alright, so propagation is that. We need to change this to a float. And then for our directions, so 8 to Alright, so we're going to want, for, let's see, direction 8, we're going to want 1.41f. Alright, this is direction 2. Direction 2, that should also be a diagonal. Direction 6 is a diagonal. Wait, what? Where's direction 7? This is supposed to be direction 7 right here. I was like, this doesn't make sense. Alright, so this is direction 3. It's basically everything that doesn't have all these things, so let's just look at this real quick. So direction 1 is straight up. Direction 7 is to the left. Direction 5 is down. Direction 3 is to the right. Direction 4. Where's direction 4? We're looking at it. So 4, 6, 2, and 8 have the higher distances. Alright, cool. So we should see that not be square now, we should see it actually fall off radially. So we get a much better idea of the distance from our shore that we are at. So yeah, basically what we're doing is we're just slowly gathering all the information that we're going to need in order to actually build our water material. And we do it one chunk at a time. And it's kind of a slow process figuring out everything that we need. But when we have all the information together, we're actually going to be able to make a pretty cool water shader. But if you don't do the grunt work of getting all the math and then drawing it out in these textures pre-computed, then, well, what are you going to do, right? This one's the distance, and we're going to need the flow field as well, for what direction the water is going to be moving, and all that. So here's our distance map. So distance from shore, and that's looking pretty decent. So if we did like 1024, how long does that take to compute? Yeah, and this actually has a little mushroom that's peeking up right there. Alright, so that's our distance from shore. That's looking pretty cool. Alright, so what we're going to want to do, I believe, is we need to scale the distance from shore value that we're writing in here by the width. So I want this to go from 0 to a maximum of 1, and 1 is the width of the actual texture, something like that. Or should we have this be in real world units? I think it should go from 0 to 1, and 1 is the width of the texture. Though, does that make any sort of sense? Like, what do we really want here? Like, I think we want a distance scale, so I mean, I guess maybe it should be in world space. And we should go from 0 to 1 based on the distance that we want. So did you manage to get to save? Yes. Basically what I did is we save our textures into our into a folder, and it's like it saves the name of the object and then the texture right in there. So, you know, we just make sure we got those things saved. And then we can restart it and it'll have those pre-cached assets there. So yeah, we had to actually save them as UAssets. So we rendered out the texture and then we saved the texture to Dashkin. Did it end up being a royal pain in the ass? Well, it wasn't really a huge pain in the ass to actually get it to work. It was mainly just finding out what actually worked because, I'm not super Unreal Master. Because all I did was I went and, as you can see, our texture is saved. What I did is I made an editor utils class for myself and just made a save texture asset and like save level specific texture asset. So basically I can get the name for the current level and get the folder that it's stored in and then go make a folder inside of the asset database and then go put the texture inside of there based on the name of the actual object. And then it's pretty simple to use from, it could be simpler, but basically from inside of blueprints you just call save texture asset and pass in like the asset folder for the current level and the name of yourself, and just it looks stupider than it is, but I just static height map and everything, and then you just set the texture for your object on your blueprint, and So when you click on it, you can actually see the textures just over here, just like you normally would with a blueprint. So, because those things are saved, we can now reference them as just, regular old view assets, and it just works. So and this has a lot of other, we probably could have got it to work the other way, but this one has a lot of other advantages, such as, we're actually saving these as U assets, so Packfile is actually going to compress them on disk, and we've got the texture streaming nice stuff that'll work in there with it and all that. We don't have to do a bunch of crazy stupid shenanigans. Like when this thing pulls up, it pulls it up just like any other texture that you would pull up in your game. It doesn't have to do that weird ass F-color conversion shit on frame 1 or something. So that was the plan, and I think it worked. So I think what we want to do for the distance stuff is we want to pass in a distance that equals 1, and then we just divide the distance by, in world space, by that maximum distance. So it goes from 0 to 1 based on the maximum distance. So what we want to do is we want to change the function inside of physics utils to take a maximum distance thing. So chord normals, distance output, get distance, and float maximum shore distance. And let's just set the maximum shore distance to something reasonable, like 1,000. Alright, so it's going to be float. We want our step distance x and step distance y. Alright, so step distance x equals the x step dot size, and step distance y equals what y step dot size. And then we've got our maximum shore distance. So for this other thing, we're just going to pass this maximum shore distance down the function chains. We're going to float max shore distance So this distance value actually is going to be interesting because it needs to be a square, otherwise we're screwed for some of this. Because if the x and y steps are actually differing distances, then we have a problem. Our algorithm doesn't cover that properly. It has a single distance value. So, what are we going to do about this? The shore distance is going to change based on the scale of this object, so I mean, we could have our x distance and y distance, and then like our total distance, but we'd have to have 3 different variables here stored to actually have the correct distance calculation. I mean, we'd want like the origin pixel, and then basically what you do is you calculate a separate distance based on the origin pixel distance to the current pixel distance in order to figure out where we are. Crap. Well, I'm gonna have to think about this a little bit. Alright, then we'll have the x step and the y step here, and then we have to do stuff with it. So we'll copy paste the hell out of this thing because we can. And I'm gonna have to think about exactly what I need for this thing. So if our object is not square, then this distance is gonna be the wrong value. So what we need to do is, like what we have now is the number of grid squares we are away. But we are not the number of x and y grid squares that we are away from an object. So the information that we'd actually need to know is where the starting pixel is. And if we knew where the starting pixel was, we'd be able to calculate a distance based on that. The starting pixel is the top level, and our grid square is still correct in terms of like that's the number of grid squares away we are. But if the distance of the grid square is different, then I mean, I guess instead of having propagation be a 1 there, we can have propagation be, like it's already a float. We'd have to calculate the propagation based on the x and y step. So it would be plus a different value, so we'd be always going diagonally and all that stuff. We just are in a different space, and since it is a grid laid out in that space, we still have accurate distances. Okay, so all we have to do is change our calculations for a propagation value. We just need the true distance that we're moving, and it's different for every one of the 8 directions. So distance is going to be, let's see, this will be 0 times x step plus, what, 1 times y step, and we'd want to square these things and do a square root of it in order to actually calculate this stuff on diagonals. Like 8 is a diagonal, This is direction 1. I should actually just label these real quick. Could you not add 2 or 3 set points to triangulate from? I am not exactly sure what you mean. Really all I need to do is just calculate the distance that we're moving along the grid square as we move across it. So when we move in the y direction, you know, that's going to be y step. When we move in the x direction, that's x step. And when we move diagonal, that's, you know, x step plus x step squared plus y step squared, square root of that. And that should do it. And then we just take this, we take the propagation value here, and we just divide it by max shore distance and multiply by 255 in order to get our color. Are you talking about how to calculate the distance from a point and stuff like that? And like, are you talking about just the algorithm as in general as a whole? Because we're not going to change that algorithm. We're going to change that algorithm. I don't think we don't need to. It works. We've got the grid all doing its stuff. We're just normalizing the color properly so that it makes sense inside of our material for what we're going to use for it. And we'll be able to change, you know, like the quote-unquote shore detection piece on the outside on the blueprint. So you can say like, you know, 2 meters, give me 2 meters from shore inside of the material, and that's what I want to use for like shore ripples. And that's the direction, this is the distance. I treat these streams like a game show. Yeah, the avoid the square problem. I mean, it's not really a big deal. This is just static calculations, and I can calculate the square root of this thing real quick, just on the outside. You know, just do x plus y and just pass that in for like diagonal step, right? And that's all I have to do. And I just pass in the diagonal step. I'm only do 1 square root. We're fine. I actually feel like you learn here. All right. Well, that's one of the things is you never know if you know think you're saying something dumb or something else. It might make me think of something in a different way, even. So it doesn't really matter. It's all relative, right? So if you're just saying stuff, then who knows? It might be cool. All right, so we just need y step here, and then we have diagonal step. Okay, so we're good. All right, so direction 8 is going to be diagonal step. All right, direction 2 is diagonal step. And this is kind of copy pasta code a bit, but I'm really not going to worry about it. Direction 7 is x step. Direction 3 is X step. Direction 6 is diagonal step. This direction 5 is Y step. Direction 4 is diagonal step. Alright, so this will be plus distance. Propagation. So we should be good to go there. Alright, so if the propagation is greater than max distance, max shore distance, then we'll return. And for all these we want, yeah, it's going to initialize it to white. And the R value well, we could just have this as a color, and then we can multiply by the... No, we need to calculate this in here. The problem is we're saving this as, you know, a byte here, so it's going to be like current distance multiplied by max shore distance divided by float current pixel distance equals this value divided by 255. And then if propagation is greater than max shore distance, and then this thing is going to be floor propagation. It's actually going to be propagation divided by fmath for propagation divided by max shore distance multiplied by 255. I think that works. Then you pass the diagonal step in everywhere. Alright, I think that works. Bunch of pre-calculated nonsense. Alright, let's think about this for a minute. So our current distance is going to be set to the propagation divided by max shore distance. That'll go from 0 to greater than 1. Alright, so we're going to do float value equals this thing right here. If value is greater than 255, value equals 255. Alright, so that'll prevent our wraparound issue that we would have just had as this thing floors itself and then sets itself to this uint 8. And we're going to try using just the, the lower precision stuff here where we only have, 0 to 255 for our color values, as opposed to having a linear color, which is an actual, short float, 2-byte float or whatever. So let's see. We've got this stuff here. Let's do our calculate. Well, let's see. What do we pass in for our distance? Our distance was... get maximum shore distance. Alright, so let's add a shore distance value here. Alright, so this shall be the max distance from shore detection. This is a float. Save that out. Set it, or get it right in here. Default value, let's set it to 1,000. And let's give a slider range. Give a slider range of like 0 to, like 10,000 or something. So I would have expected these things to go to 1. The code is different from the original version. What changed? Did my code changes not get added? Well, let's just make sure that they will. That can sometimes happen with Unreal and Visual Studio and all that stuff. It has kind of this incremental build process thing that can sometimes, you save a file and build it and it doesn't always get it because of DLL or whatever stuff. Happens rarely. Which mainly you would have had the warning in Visual Studio that said like, you're using out-of-date code, would you like to rebuild? But you have to turn that off with Unreal because it doesn't respect everything properly, and Visual Studio gets all angry at it and like, well, every single time it's new, and it's like, well, no, it's not. Unreal just changed some timestamps. Was Unreal the first big engine to allow you to compile while using the engine? Well, any program that like can hot load DLLs and stuff like that, you can, compile while using the engine. I mean, it also like, what do you mean compile?